So like I mentioned before, we are going to dig into the multi-system setup of our application using the tools we have seen so far in the loopback case. So first thing we are going to do in this new setup is making sure that our client and server works exactly as it is. So the client code is this, no changes other than this IP address. We have discussed this is the IP address of the server. We are yet to see the details of IP address or port, but at the moment we know that it is the IP address of the server. That's the only change we have made in the program so far. Now this is a server. It is a different computer altogether. And there also the change is this, the IP address. In this case, we are not mentioning any IP address, especially we are not mentioning the client IP address here. We'll discuss the reason for all that later, but this is the only change we are doing. I'd like to undo some of the experiments we've been doing. So this code I will uncomment to look like exactly how it was before. So the other print statements I will keep as it is. I'm not removing. Other than that, there is no changes. Let me save this change and run without debugging. So we don't need much of debugging anymore because we know what is happening. So we'll be simply running these stuff. Now, again, I'm just running everything, running the client. Server is already running just to make sure that everything is working as expected. One of the things you need to take care if you're running it on Windows, for example, is to turn off your firewall. So Windows has this firewall. I'll quickly show you. By default, it is turned on, but sometimes you need to turn it off in case if it is on to make sure that it works. Firewall is a different topic altogether. We will have that topic coming up, but for the time being, just turn off the firewall. So everything is working as expected. Things are fine. In case if you're doing this demo, make sure that you get here before you start exploring. So let me show you the firewall thingy. wf.msc, that is the command for firewall, Windows firewall. This is a Windows local firewall. Even Linux has a local firewall. If it is enabled, make sure that it is disabled, whether it is IP tables or firewall D, you need to check. So go to firewall properties, you will get a window like this and make sure that it is off in different profile. These profiles are Windows specific thing. We will not get much into it, but make sure that everywhere this is off. So if the firewall is off, it will show like this red shield button. So that's what we want. Make sure that in the client as well, preferably the firewall is off, but normally the client firewall normally doesn't cause any problem. Firewall definitely cause problem if this port number is less and firewall is on. So make sure that you don't forget it. So right now our code is working in two different systems. Now what we are going to do is we are going to look at a couple of tools here. So what I can do is I can start with TCP view. We will not be looking at netstat or any other tools. TCP view, we are going to stick with TCP view for the time being. Also, we won't be looking at resource monitor. We have seen netstat, TCP view and resource monitor. All of them were showing us pretty much similar information. So I'm going to run the server again. This time I'm starting without debugging. The server is running as expected. And I'm coming to the client machine. And here I have a breakpoint right here after the connect. So what I'm going to do is I'm going to start debugging. So before send hello world, we will look at TCP view. Just like before, I'm starting TCP view and filtering for the port 65432. So in this case, we have only one socket in the client machine. So this is one thing we need to observe. This is the difference we are observing right here. There is only one socket or one line in our case. So this is our client system. Remember, the bottom part of the client system is this particular color, Windows 11, and the server is dark black kind of color. So this is a client system. So we have only one line and the state of the socket is established, as you can see here. Now the local port is a client port, which is a random number, and remote address is the host name of that server. So we'll change this option to see the IP address, and remote port, that is what is interesting to us, 65432. We don't have the listen socket, and we don't have the other socket which the IP address and the port number was altered. That we will see in the server computer. Now, one thing I would like to show you is I'm going to uncheck this resolve address so that we can see the IP address. So local address, so this is the client address 172.20.10.3. We have discussed 3 is the client and 6 is the server, 172.20.10.6. Normally when we speak IP address, we don't talk about this dot in between, but you can say 172.20.10.6. There is nothing wrong in it. So this is what I wanted to show you in the client side TCP view. Now let's have a look at the server side TCP view. So we have TCP view downloaded here. I'm just extracting and opening it up. Again, I have applied this particular filter on the server, and the other two sockets are on the server side. So this is the server machine we are looking at, and the listen local address is 0.0.0.0, and there is no valid remote address for a listen because listen socket is not sending any packets. Doesn't mean anything. Remote port 0 doesn't mean anything in a practical sense, but the corresponding established socket is right here. In this case, the local address is the IP address of this particular system, which is 172.20.10.6. And local port is, no surprise, 65432. And 172.20.10.3, that is a remote address, which is our client computer's IP address. And remote port is again a random client port. It looks very similar to the ones we have seen before, but in this case, one socket is on the other machine. Two are here in the server, the listen as well as one established. So that is all I wanted to show you in the case of TCP view. You will see similar things in netstat and network monitor. I will leave that to you as an exercise. Feel free to do it. If you face any issues, feel free to reach out. We'll dig it together. Now, next tool I wanted to show you is process monitor. So what we are going to do is we are going to restart our application and we are going to start procmon at both sides simultaneously. So I'm going to close this TCP view and I'm going to start procmon here, process monitor. Again, I'm extracting. It's all downloaded from the same place. I have started procmon and I'm going to capture straight away. So I will stop capture for the time being. Just I wanted to restart the server in a clean state. I am clearing this log because it's not related. The server is still running. I'm not much interested in the output of it. I'm going to restart debugging. So server is running just like before. Now I'm going to start capture. This is a start capture button in the procmon if you're interested. So the procmon is running on the server along with the server itself. So now let's get back to the client. So this is a client. Again, I'm restarting the client, going to the procmon, again, starting the procmon, resetting the old filters. Procmon is running, going back to the client, and I'm going to remove this breakpoint and running the client without any breakpoint. Remember, we don't need any breakpoint for procmon. Procmon is like a video getting recorded. Because it's a video, we don't need any stopping points. So it has a recorded, I hope. I'm going to stop capture here and I'm going to stop capture on the server as well, because we don't need procmon to be running for so long. Make sure that you turn off procmon as soon as you're done with your capture, because procmon can hang your system. It's a very resource intensive workload as far as the tool is concerned. So make sure that you turn it off once you have done it. Now our filter is exactly same as before. Path contains our port number 65. We are adding to it. Apply. We'll be applying this filters pretty much on the server as well. So this is a client side, and we are going to do the same thing on the server side as well. Again, going to filter, path contains the port number. So there we have it. In this case, we have only one process ID, which is a server. Previous case, we have two process IDs, the server and the client, because the server and the client were running in the same system. That's why we had two process IDs. Now it looks very simple. So what are the action performed by the server? It is the accept, pretty much looking like the code itself. Accept, we have seen that before. Receive, send, and disconnect. So this is the part of the three-way handshake, and this is the data transfer happening here. This is receiving data and this is sending data, and then disconnect. Sometimes proc1 shows copy and other function calls, internal function calls in Windows, but doesn't matter to us much. Now, if you look at one of these stacks, unfortunately I have no symbols configured here because I don't have that DLL in the system, but you can see TCP IP on the stack. If you care about the function names, feel free to set the symbols correctly, but we have set the symbols correctly in the client. So that's why we are getting this big numbers instead of clean function names, but we can see TCP IP. But I promise you that the stack will look pretty similar to what we have seen in the previous session, because the TCP IP stack is exactly same as before. No changes there. Probably there are a couple of changes because of the operating system, not because of the change of computers. Now coming back to the proc1 on the client. So we have the connect on the client. Here also, if you look, we will see just one process, which is a client process, and we have all the connect, send, and receive and disconnect. Pretty similar to server, except one thing. The server has accept here while client has connect. That is the only thing you need to worry about or pay attention to. Rest of the things going to be looking very similar. The stack is pretty similar as before. In the client side, we have the symbols. That's why we are getting this detailed function names. Right now, the VirtualBox is hooking into the stack. I'm not going into the details of it. Because of that, the VirtualBox is also coming in the stack, which probably might not have been there if VirtualBox was not there in the picture. Doesn't matter to us much. What matters to us is the presence of TCP IP on the stack. So if you want to see a very clean stack without all this extra stuff, I would recommend you do this experiment inside two different computers, which I'm not doing. I'm doing it in a VirtualBox. That's why VirtualBox is coming into the picture. That is also the reason why we cannot run a Wireshark in the client computer. But that's okay. We are going to run Wireshark inside the server. So that is the tool we are going to look at next. We are going to look at Wireshark. So in the case of Wireshark, we are looking at a data transferred. So either way, the data transferred between client and server is going to be same whether you are observing it from client or server. So in our case, we are going to observe only from the server for a particular reason. But if you're doing this properly with two different computers, you can run Wireshark the exact same way we are running in server and see the exact same packets. In our case, we can't do it easily, at least because of VirtualBox coming into the picture. Doesn't matter to us. We are going to look at the exact same thing from the server anyway. So I have only one Ethernet adapter or a NIC card or physical device. It's actually a virtual device. The address is 172.20.10.6. So this is the server. I'm going to double click on it. And if you remember, we need to apply our filter. Otherwise, we'll see all kind of different packets. TCP.port equal to. So don't forget the double equal to 65432. So this is the filter we need to put. Now I'm going to start the server. Run, start without debugging or with debugging. Doesn't matter. We don't have any breakpoint anyway. So again, I'm starting the client. Don't have any breakpoint here as well. Start debugging. Yeah, all working. Let's see if we got something in the Wireshark. Yes, we got exactly what we want in the Wireshark. Now, the only difference from what we have seen before is the source and destination IP addresses. In this case, the source is a client IP address and the destination is server IP address. Everything else is exactly the same. If you look, synac, ACK, push-ACK, finac, ACK. Couple of packets are in slightly different order. For example, we don't have ACK for the push-ACK. We don't have ACK for the finac. Such things are different. But don't worry about it. Our TCP handshake, three-way handshake is there exactly as it is. Our hello world is there exactly as it is. And our hello world from server is there exactly as it is. So this is the finac from the server and this is the finac from the client. Server is sending ACK to the client for the finac. But essentially it is exactly same thing. So to conclude, we have seen the output of different tools in a multi-system scenario. We have seen the same tools, including Wireshark,